Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter Gravitation, came in a JEE 2025 exam, important for NEET and CBSE both. Okay, so let's go through the question. The question is, a satellite of mass m/2 is revolving around Earth in a circular orbit at a height of r/3 from Earth's surface. Now, the angular momentum of the satellite is given this one. After that, the value of x is how much here? In this expression, what is the value of the x? And other data is given. What is this? Where m and r are the mass and radius of the Earth respectively. G is the gravitational constant. Okay, so here I have taken here. Let's take this is the Earth. Mass how much here? Mass of the Earth is m. And let's take the radius r is there. After that, see here. From the surface here, one satellite is there. This is the satellite. How much mass is there? The mass of the satellite is given here m/2, and it is revolving in a how much height? Height is given r/3. So think please. This is r, that means radius of the Earth, and height how much here? r/3. So the distance of the satellite orbit from the center of the Earth will become how much here? Let's take here, this is small r. Okay, so this small r value will be how much here? I am writing here, this small r value will be r plus r/3. That means this will be 4/3. That is the orbital radius of the satellite here. Is it? Now, after that, let's take this satellite is revolving with the speed v0 here. This is called the orbital velocity v0. Okay. So all this data we know, we have got the r, we have got the v0. Now the main thing arises, what is the angular momentum? Okay, so see here, remember that the angular momentum basic formula is in a vector form, L equal to r cross p, in a vector form. Okay, but if we apply for circular path, which path here students? For a circular path. So for circular path, remember that here I can write the magnitude. And how to get the magnitude? See, I am writing here the magnitude. The magnitude we can write here, mod L means mod of r cross p, and this used to be rp sine theta. Is it? But in a circular path, what I told you, circular path, see, this theta will be 90 degrees. That means angle between this position vector and linear momentum will be 90 degree always. Okay, so in this situation, remember that here we can write here, hence L will be, I am telling the basic, it will become here r, p is the momentum, that means mv, and here how much here? Sine 90 degree here. Okay, so from here I can write here, this L is given here mvr. What is the formula? The formula of the angular momentum is the, for circular path only, what is there? mvr. After that, mass of the satellite is given, speed we have to calculate, and r also we have given how much? 4r/3. Is it? So that all these things we are going to use it. Okay, so let's go through it. Is it? So to calculate the angular momentum, we have to calculate the orbital velocity also. So remember that here, this orbital velocity of the satellite will be root gm/r. Why? Because gravitational force acting between Earth and the satellite will provide the centripetal force. Is it? So from there only I will get here the orbital velocity. Is it? How to get here? I am telling you the basic. Okay, basic. So see, what is the basic here? I am telling you, this Fc will provide, this centripetal force will be what? Gravitational force. Okay, and what is the Fc will be? Fc will be mv0 square by r, and this gravitational force will be mass of the Earth by mass of satellite by r square here. Is it? So from here, when you will simplify v0, you will get here this expression, root gm/r. Small m will cancel out here. Okay, so from here we can write here, see, orbital velocity, this is root gm, and r value, what we know here, this r value is 4/3. Is it? 4/3. This is the orbital velocity. Again, now after that we have to, just very easy, we have to calculate the angular momentum. What I told you, mv0 into r. Is it? What is the mass of the satellite? m/2. Is it? And what is the orbital velocity? You can write very well. 3 will go up, that means it will become here root 3gm/4r. And what is small r? You know very well. See here, this is small r is how much here? 4r by 3. Now let's write here 4r by 3. Okay. So after that, when we'll simplify this, what this will become here? Kindly see very well. See, m by 2 into root 3 gm by r. 1 by root 4 means it will become 1 by 2 into 4r by 3. Is it? Now what are the things will cancel out? Let's see here. This 2 is cancelled by this 4 here. Is it? And you can see very well here. Here r by 3 is there. Now so see here, root 3 gm by r. If I will keep in a inside a square root, it will become here, what we can tell here, r square by 3 square here. Now this thing, this r by 3 I have taken inside. Now what will happen actually, students? What will cancel out here? Again see, from this r, 1 r is cancelled, and from this 3, 1 3 will cancel. Okay, that means we can write here very easily, L equal to, it will become here, kindly see here, GMR by, what is left here? Only 3. Root GMR by 3. Kindly see very well. Is it? So root GMR by 3, and this side what expression is given here? Root GMR by X. What they have given here? Root GMR by X. So when we compare, here you can see X, here we can see 3, hence what is the value of the X? The value of X will be how much here? 3. Is it? Can you see here? So students, no, here the value of X will be how much here? 3. Now, so this question is very, very clear to you based upon the angular momentum basics and all that. Okay, keep studying, keep growing.